The term black hole is of very recent origin. It was coined in 1969 by American scientist John Wheeler as a graphic description of an idea that goes back at least 200 years. At that time, there were two theories about light. One was that it was composed of particles, and the other was that it was made of waves. We now know that really both theories are correct. By the wave and particle duality of quantum mechanics, light can be regarded as both a wave and a particle nature. Under the theory that light was made of waves, it was not clear how it would respond to gravity. But if light were composed of particles, one might expect them to be affected by gravity in the same way that cannonballs, rockets, and planets are. On this assumption, a Cambridge John Michael wrote a paper in 1783 in Philosophical Transaction of the Royal Society of London. In it, he pointed out that a star that was sufficiently massive and compact would have such a strong gravitational field that light could not escape. Any light emitted from the surface of the star would be dragged back by the star's gravitational attraction before it could get very far. Michael also suggested that there might be a large number of stars like this, although we would not be able to see them because light from them would not reach us. We would still feel their gravitational attraction. Such objects are what we now call black holes, because that is what there are black voids in space. A similar suggestion was made a few years later by French scientist the Marquis de Laplace, apparently independently of Michael. Interestingly enough, he included it in only the first and second edition of the book, The System of Worlds, and it left it out of the later edition. Perhaps he decided that it was a crazy idea. In fact, it is not really consistent to treat light like cannonballs near Newton's theory of gravity, because the speed of light is fixed. A cannonball fired upward from the earth will be slowed down by the gravity and will eventually stop